do a little recap before we can actually
Okay,
continue.
okay,
Yeah.
okay, no problem. I'll do that.
All right. Okay.
Can you guys see my screen? Okay. So Jethro requested that we start all over. Um,
Sorry, man, we can't see your screen. I don't know if it's from my end. Yeah.
can't still see it. Okay, let me stop sharing and share again. Can you see my screen now?
Yes, it's visible.
So Jethro, in the morning, we uh, we were looking at introduction to Rust and blockchain and why we use Rust in blockchain. So Rust being a very powerful language because it's a system programming language that's focused on safety, performance, and concurrency. So the key features that if you ask anybody writing Rust why they love Rust is because of the memory safety, the performance, the concurrency, and the ecosystem. So in memory safety, like it doesn't waste memory. It helps allocate the right portion of space for anything you want to use it for. And then for performance, it's fast, is a no garbage collector, and then it's also a safe multi-trending because it uses the async await. Then it has vast library, like we have library for Bitcoin, for Ethereum, even normal backend and the rest. Then I think your first class in this bootcamp we spoke about blockchain being a decentralized immutable ledger for recording transactions across network. Now this is everybody or anybody that wants can be a node. Node is just a computer that has exactly the same thing across the world. So if I'm having 1 plus 1, every other person across the world is having the same thing. So the aim of blockchain is for the transparency, it's for the decentralization, it's for the consensus, and then also the last but not the least, security, because it is secure. Before you want to hack or do anything, you need to have a high computing computer. Now, Bitcoin uses proof of work. You have to solve a lot of maths to get a block on the blockchain, to add a block on your blockchain. And then before they will now pay you, all those work, you before you even think of, okay, let me hack this and ship this money, you spend a lot of resources. Then the Ethereum uses proof of stake. Yes, where you stake money, I think 32 ETH. So if you submit a block that doesn't match with every other person, or you try to blockchain, I told you we have the safety, prevent bugs we handle multi-transactions and network.
Yo, sorry guys, did the mentor leave the call?
I think he's having network challenge. She's having a network challenge.
What? What's wrong?
It seems like a
Wow.
network problem. Hold on.
Okay, let me just hold on. I'll reach out to her. Just hold on. All right, so I'm trying to reach out to the mentor. Just hang on for Moment, please. All right. It would be boss. How far? I don't know if you could hold up for Stephanie, probably before she comes back.
Mr. John, presently I'm not with my system now. I'm just with my phone. I joined with my phone.
Oh,
What number?
oh, I see. No issues. No issues. Let me still try to reach out to her. All right. So she'll be rejoining in a moment, please. Yeah. So let's just hang on.
Hi guys, can you hear me?
Yes, we can hear you clearly.
So I think what I will do for all this network thing is that I'll just record myself teaching everything again and then send it again. Then if you have any question, depth hour, I'll be there Saturday, or we can choose maybe Friday so that you guys can have your depth hour. Then you can ask me any question concerning it. But for the meantime, you can still go over it. Jethro, please, where did you stop hearing me before I went off?
Okay, you were actually talking about the security of Rust, how it is being secured when you are right, like something that has to do with the security. Yeah, that was where I stopped hearing. Are you with me?
Okay. Okay. Yes, I'm with you. I'm trying to share my
All right.
screen. So is it why Ross for blockchain? Is this where I stopped? Is
Yes,
this
yes, yes,
where you
yes,
stopped?
yes, yes.
Um, can you like tell me the last thing I said so that I can know where to continue from? Okay.
But I
So
think you can just start from slide 4.
why
Why Rust?
Ross for blockchain?
Yeah, yeah.
So why is Ross used for blockchain? Ross is used for blockchain because it's memory safety. For the safetyness, we can say it prevents bugs because the moment you have like any issue in your Rust code, it's just going to throw the error immediately and also prevent bugs in critical blockchain system like in your smart contracts because Rust is a very strict language. Then in performance, efficiency for node implementation and cryptography operations. Then in concurrency, it handles multiple transactions and network requests safely. Then we have a verbose libraries in Rust. We have Rust for Bitcoin. I think I've used that. We have Rust for partly Ethereum. We have Solana, SDK. We have Polkadot too, and other ecosystems that uses Rust for their blockchain. Then we know that we use Rust to write smart contracts, and smart contracts being a self-executable code. That means every logic that you write is what is going to be implemented. So if you say A plus A, nobody can come again and change it or reverse it. So that is where the security comes in because you can't mutate the blockchain, you can't change what is there, you can't change the state of the blockchain. Then we are going to dive into Rust now, talking about the variables, talking about the variables. Okay, yeah, yes. So Rust being a immutable, Rust variables are immutable in such a way that you cannot change the variables. If you declare X to be 5, you cannot come back and say X is equal to 6. So we are going to be doing hands-on practical here. So I'll just comment this out. Yeah. So let's end. So this is how to create a function. Without this main function in your Rust code, nothing will run. X, okay, let X equals to 5. So we can come and say that X equals to 7. And then now let's read this warning. Cannot assign twice to immutable variable X. So if we try to do cargo run, should I zoom in? Can you guys see my screen very well? Hmm? Yes, Johnson, you can talk.
Sorry, ma.
Should I
You are
zoom?
talking about the cargo, and we don't know what is cargo or all these toolings you are talking about. Too.
Oh, oh, okay, okay. I missed a part. To get started using Rust, you need to first install all these things. Cargo is like um is the compiler that helps. It just helps you compile your code to bytecode that your computer can understand that this is what you're trying to see and gives you the right output. So I think let me. So this is like the link to this command, this link here, or this command to install Rust. When you install Rust, that is for Mac and Linux. Then this is, I think I should share this document. So you follow the steps here to download or install Rust. Then how to create a new project in Rust is using cargo init, then your project name. I think I did it here. Cargo init Rust class. Then it's going to create a whole full template that comes with this is src file that has the main.rs. So when you're running a cargo run, is to compile your code. This cargo run now is only checking for the code in this main.rs. Then whatever is being compiled here is going to be moved to your target file. So this cargo.toml is where you add all your dependencies. If you're building a very big big project. Let's say in Node.js now, it's your package dot lock. The no, that's not your package dot lock. In Node.js, where all your dependencies are, it's just like this cargo.toml in Rust. So is that any question concerning that? Hmm? Johnson, any question? Johnson, okay, no question. So like I was saying, Rust is an immutable variable. From our previous example here, and the error is throwing it, you cannot assign twice to an immutable value because X naturally it's immutable. You cannot reuse it like JavaScript. If it's JavaScript now, this can work. Let me um, I do let X equals to 5 and do X equals to 6. Now in JavaScript this will work, but in Rust this can never work. The only way this can work is to add the mute keyword. So you're not telling the compiler you can mutate this X, you can change the value of this X to anything, but you must add this mute if you're trying to update the state of a variable. Then our next concept is shadowing. As you saw in, okay, we didn't do the guessing tutorial. So shadowing is like using a variable with the same variable name and repeating it with a let keyword. So you're just reusing the variable name, but it's like it's being stored in a different memory stack. So let me show you this example. I think we did this in the class. Hmm. So this now in line 2, we all understand that we are assigning x, we're assigning 5 to x, and in line 4 now, we're going to use the value from line 2, and it's going to be 5 plus 1. So line 4, the x there should be 6. So in line 11, we're expecting 6. Then in line 7, I see this thing as global scope and local scope in JavaScript. This should be like your global scope, and this inner one here should be like your local scope. So in this, the x now, this x now will be this x in line 4, and which we previously say that is 6. We are saying 6 times 2 is equals to 12. So when we run this code, we should expect that our local scope should be 12 and our global scope in line 11 should be 6. So let's check and see. Yeah, the value of x in the inner scope, as we said, is 12, and the value of x, probably global scope, so just put global scope is 6. So, is there any question on this shadowing? Any question on shadowing?
You're moving your screen too fast. What is this?
Okay, okay, sorry. Any question? Should I give you time to look
No.
at it? Should I move on?
Yes, please.
I can move on.
Yes, ma'am.
So on to the next. We are moving to constants. Okay. Constants are like immutable variable. Constants are values that are bounded to a name and are not allowed to change. So it's just like, let's say constant is like your face. Your face is always your face, whether you're small or you're big. It's just that with time, with little changes, but your face is still your face. So you cannot mutate constant. It is immutable. If you like, add the mute keyword. It will just never work. Let's check. For example, let's use this. So let's see if we can see. I added the mute keyword here and it's saying const global cannot be mutable. Cannot be mutable. Or you did not add the keyword mute. It is immutable. There's no magic or juju you want to perform that can make it immutable. That can make it mutable. I think that one is quite easy to understand. Then, okay, that's all. We are moving to data types. And in data types, we have, okay, you can go ahead and ask your question, Adi.
Okay. Okay. For constant, does shadowing also work for it?
No,
Okay.
no. Or should we try?
Yes.
Local binding. No, shadowing does not work for constants. Is your question answered?
Yes, thank you.
All right. So I'm moving to data types, and we have two types of data types. We have the scalar and we have the compound. In the scalar, we have the integers, we have the strings, we have the characters, we have boolean. Then in integers, we have two types. You have the signed and unsigned integers. Okay, let me know just speaking English. So see it here. Scalar represents single values. Rust has four primary scalar types: integers, floating point, numbers, booleans, and character. Then integers, like I said, we have two types. The signed integers type starts with I, and the unsigned starts with U. So that takes us 32 bits of space. So this is it. This time we have I8, I16, I32, I64, I128, and I time. Then we have U8, U16, U32, U64, U128. Then there's this concept we have underflow and overflow. In underflow, let's say just a very a real time example now. Mm, okay, let's go to overflow. Overflow is like a cup or a stack can only contain 10 chairs, chairs, 10 chairs of stack. But somehow you're forcing the, the stack to contain 11. You're, so in doing that, you can say that the stack is undergoing an overflow because it's containing 11 stack of 11 chairs instead of 10. Why underflow is like the opposite. It's not containing enough or it's like being downgraded. I'm not using the right example, but I feel like if you understand the overflow is just the opposite of the underflow. But let's see what Ross has to say. Integer overflow. Let's say you have a type of UA that can hold 0 to 255. If you try to change the variable to an outside variable such that 256, integer overflow will occur. So because this U8 can only hold 0 to 255, so it can only hold a 256 values. But all of a sudden, you want it to hold 257 value. So it's going to undergo an integer overflow in it, and in security it's a very serious issue because if you write that in smart contracts and a hacker sees that, you can use that small overflow to wipe all your money in your account. So we have floating points. Floating points everywhere is a decimal number. We have F64, F32, F8, and the rest. Then we have numeric operation like addition, subtraction, multiplication, division, remainder. I believe we are familiar with that one. All these things is still under the scalar type. So then we have boolean, which is just true or false. It's just a two value, true or false. It can never be maybe. Then we have the character type. the character types. You should note that in Rust for strings, and we use the single quotes for characters. Looking at this now, let's let's quickly. So it's either you do it this way or you explicitly tell the compiler that this is a character. But I want to show you guys something. You see here, it's already giving me that. You see this string stuff. Yeah, it's already showing me that, oh, this is a string because we use the double quotes. But let's assume I change it to tab. What will happen? Mismatch types. Tab found a string. You're saying that you're saying that this A should be a character, but then you're defining a string. So we should be very, very careful. People coming from JavaScript background. Okay. Yes, result. Then our compound data types, we just have two. We have the tuple and we have the array. So difference between tuple and array is that all of them holds the group data together. But in tuple, we can have many or multiple data types inside the tuple. For example, this one we have I32, a floating number, and we have an unsigned integer. We can also have a boolean. Let's try and see. Come in and have two. You can come in and have, okay, we start down with tuple. You can come in and have two. And also, I think for now, because I wanted to add an array of another tuple, but it's going to be too much. So tuple binds the entire tuple together and considered a single compound element. So this is another way to write it. You can either write it this way or you write it this way. Exactly. Any question? Any question? So we have array. Array, unlike the tuple, you can only store the same type. So if it's array, let's so yeah, we're saying that this array, this array should contain only one this data type assigned integer 32, and it should hold five elements. One, two, three, four. Like if I try adding another one, mismatch types expected array with a size of five, found one with a size of six. So if I delete it or I try to add, make this 5 a floating number, say mismatch types, expected I32 found a floating number. So array is very strict. You just need one data type and the size. But I think this is a fixed array. Fixed array is where you define the size of the array. Like when you're already sure that this array is going to hold this exact amount of items, then you can define it like this. But along the way, we see how we can mutate an array. So the next one is accessing an array. You know that um arrays or yes, arrays always start with 0, 1, 2, 3, 4, 5. So when accessing the first index, let's say you want to get number one. Number one using the computer ways. Number one is index 0. Number two is index 1. And then number 5 should be index 4. Because yeah, according to computer, we will have those 4 index. Then a question from what I've been saying since. Any question? All right, Adi.
Okay. In Rust, can we have different types? Like instead of having a type of integer of 32, can we have like a combination, like the way we did that tuple? Is something like that possible in array in Rust? Like having different values in one array?
No. Array,
Okay. Okay.
array is just one data type. If you're using boolean, it's just a boolean. If you're using sign integer, it should be sign integer. And sign integer, if it's I8, it should be I8. If it's I32, it should be I32. So have I answered the
Thank
question?
you. Yes, you answered it.
So next we are writing this. I'm going to explain this whole concept of this big code we are seeing here. I already have it here. Hmm. So line one now. Line one is a standard library. If you're coming from family of C, we always use standard libraries first, or even Python or JavaScript, all those imports, React, or import Express from Express. So this is a standard library, and this standard library will all read it together. Maybe I keep it. So this is the standard library. This is the best way to learn. If you don't know it, browse it, go to the documentation and read it for yourself. And don't say somebody said that stdio. So according to those documentation, the std.io module contains a number of common things that you need when doing an input and attributes. What all these things is saying is that, let's say in JavaScript we are using prompts. If you prompt what is your name now, the user is supposed to type some things and you get the value, then you compute it and you produce an attribute. Right? It's the same thing here in Rust. Rust, we are importing this input and output standard library, and then we are creating an array of I32 with 5 elements in it in line 4. And then we are asking the user, we are printing to the console, please enter an array index. And then in line 8, we are creating a mutable in variable called index, where the user can enter whatever they want to enter. Is going to be stored in this variable called index. Then we're now using this standard library. We are calling this standard variable in line 8. And then we're going to use it. We're going to read what the user types. And then we're going to come back here in line 14 and trim and process whatever the user wrote. And then we're going to check if whatever the user wrote is in this A, if the index exists. Now in this A now you can only get from index 0 to 4. So if the user types like index 6 now, it's going to show the value of the index. Let's just do it. So it's asking me please enter an index. I'll just enter, I'll not enter anything. And the first error, index entered was not a number. This is the error it's reading. So it's processing whatever the user wrote here. In line 17, index entered was not a number. Let's run it again. And I write index 9, knowing fully well that there's no index 9 in this A. I wrote the length is 5, but the index is 9. The length of this thing, of this array here, is 5. But then I'm trying to access an index of 9, which doesn't exist. So let's go again. Let me access index 3. Yeah, 3. The index, okay, the value of this element at index 3 is 4. Yes, 0, 1, 2, 3. And that's how we got the index 4. Is there any question? Is there any question? Yes, I did.
Okay, that string that you declared before using std in, What was the string doing?
Which string?
The
Line what?
line 8.
Okay. So when we ask the user, please enter an array index, and the user enters something, we are where is that number or that value? Where is it going to be stored? That is why we created line 8, so that whatever the user types or sends back to us will be stored in this index. Do you
Okay.
understand? So
Okay.
it's not this index now that the standard inputs and output library is going to read from. That is why it's called read line. So when
Mm-hmm.
it's ready, then it's going to give us a handle, like a proper error message. If you
Mm.
can read it, it's going to tell you, yes, okay, I read it too. Then it's going to throw this error if it's wrong. If what we gave it is not what is expected, then it's going to come back here and throw this error. But if what we gave it is right, then it's going to come to line 21 and give us the index.
Okay. Okay. So when it reads it in, was it a string? Like
Yes, it
the
reads it as a string.
okay. So is where did it pass it? Like back to number before retrieving it? Because index is integer, right?
Mm-hmm.
Okay.
Okay, you're asking where the code conversion
Uh,
came in.
the conversion came in.
Yeah.
Okay. Wow. Oh boy. That's crazy. Okay. Wow. Thank you.
Yeah, it's changing the okay. So we are moving to functions. So if you have any question on variables, mutability, data types, you can ask now. Any question on percent, not question. So function is a group of code that can be reusable in your code base. So in languages like C, like Rust, the main entry point is your main function. Like I said, whenever you run Cargo run, in your main function. Any code that is not here, the compiler doesn't even know that that code exists. So let's read what the doc says. Functions are prevalent in Rust code. We've already seen one of the most important functions in the language, the main function, which is the entry point of many programs. We've also seen the fn keyword, which allows you to declare a new function. So this fn keyword is what we use to create function. Rust code uses the snake case as a conventional style for functions and variables like this, another function. This is the snake format. So let's try this example. So let's check what this thing is meant. This main function, they created the main function because this is what the compiler, this is our entry point of the code. And this main function has a hello world. So when you run this thing, it's going to print this hello world first. Then we have another function called another function that prints another function. And then, like I said, if for the compiler to run this another function code, we have to add it in this code. Let's run this thing and see. So it's going to give us hello world and another function. So let's comment before this another function. And now the compiler will not even notice that this function called another function exists. Because if you read the warning, it says function, another function is never used by default. Let's run our cargo run. This cargo run now we only print hello world and ignore this another function. Yeah, fix. So in your Rust code, whatever you did not put in your main function will be totally ignored. It will not, the warning will always show you that warning, another function is never used. It doesn't even exist in the compiler. So it just, the compiler will only compile this main function. And then this another function will be like, I don't even know you. So hope that one is understood.
Yes.
Is it understood? Right. Then we have parameters. Oftentimes, people or developers mistake parameters with arguments. So now let's know fully what parameters is according to Rust documentation. You can define functions with parameters with special variables that are part of the function signature. What I just saying is this x here is a parameter. This 5 here should be the argument. So technically, complete values are called arguments, but in casual conversation, people tend to use the word parameter and argument interchangeably for either variables in the function definition or complete value passing when you're calling the function. So when you're calling this function and you know that this function expects a variable because it has one parameter here, the variable that you're passing into that function is called an argument, not a parameter. Is that one should be simple programming logic. everybody know. But I just don't want us to be changing the word. Then let's read further. The declaration another function has one parameter named x. The type of the type x is specialized as sign integer text 2. When we pass 5 into another function, the printl micro puts 5 in the pair of curly braces containing x as a formatted string. All this long grammar is just trying to tell you that this x will be placed here. This print L macro is just this exclamation mark that makes the whole thing macro, and we'll go. I'll explain what macro means like later, probably my third lecture with you guys or class with you guys. Well, that is just what the whole grammar is saying. Then, yeah, in this example now, let me copy. Now, can someone tell me where, tell me the parameters and the argument? So I'm waiting, or if I wait long enough, I will just point anybody. So I'm waiting. Someone should tell me the parameter, yeah, and the argument before I point. Or we'll not move forward. Oh yeah, Ade, tell me
Okay.
to
The
us.
parameter in function print label are value, unit label.
Mm-hmm. All right.
What? Okay.
And the arguments.
The argument is 5 and h.
All right. Thank you for the trial. You got it. So let's go to statements and expression. This is something that gave me this issue why I was learning lost. So statements are like instructions that perform some actions and do not return value. Remember the keyword performs some actions and do not return values. It performs action and do not return values. Why expressions evaluate the resultant values. So obviously the expression return values. Let's see. We have already used statement and expression creating the okay. So let's y equals to 6 is a statement. Yes, this can never return a value because there's nothing to return there. I'm looking for an example of an expression. Mm, mhm. Expression evaluate values and make up most of the rest of the code that we write in the rest. This is an example of an expression. Let y equals to let s equals to 3, x equals to 1. I will just say like expression does all these mathematical or all these anything that has to do with so much logic that you need to calculate for a resultant is an expression. And note that expression do not have semicolon. See, in this one, it do not have a semicolon, but in this, it has a semicolon. Any question on that? So let's try putting a semicolon here and see. So, number one, why does, can someone tell me why expression does not have a semicolon? Just logically. Someone should just tell me why it's throwing an error. If you don't talk, we will not move
Maybe,
forward.
maybe
Or I will
because
just,
semicolon means an end of a statement. That's like full stop or so. I don't know. I don't know.
yeah, yeah, that's what semicolon, yes, that's what it means. So it means you're terminating this whole thing. But without the semicolon now, it can retrieve the value from you and you can just add it to this. Well, all these things become simple when we start using smart contracts. We will now know if we truly understand what our sense is. So let's run the code. The value of x is 4, obviously. Functions with returning values. What else? Tomorrow we'll do ownership, struct, enums, and then if time permits, we'll do 7 too. Managing growing projects. So functions with return values. Functions, okay. So this is the only thing that differentiates a function that returns values from a normal function definition. This is a normal function definition. This is a function that returns value because of this arrow thing here. Any questions concerning it? So let's see what is happening here. We created a function called size that returns an I32, and in that function it returns price. Then in our entering point function called the main function, we created a variable, and this variable is bound this function. So we're assigning x to this function, and this type function contains type. That is why if we run this code will give us that the value of x is 5. Did we try it? Mm, let's try it. Okay. Hope this one is clear. Can I move forward? So any question? Is there any question?
I think no, ma.
Hmm? We should move on.
Yes.
If you say we should move on, who is talking, please?
Please, we can move on.
Code
Ma.
for us
Yes,
on
you
what
can
to
move
use.
on, Mo. I can hear you.
Yes, someone can explain this code for me. Explain for the whole class what it does and the results, the expected results.
Can I try?
I'm writing that. Yeah, you can try. Free word.
Okay. So, the we declare the function name plus one, which is down. So since the main function is the entry point,
Mm-hmm.
so
So what does,
okay, so we
what
declare
does okay,
we
explain
declare
what the small function does.
huh? Okay, the yes, what the plus one is doing is taking in an argument. It will take in an argument, then add the argument plus one, as in increase it, and return it. After adding it, it returns the value. So whatever value that comes in, let's say for example, 5 comes in as an example now. The 5 will be added to this 1, then it will return 6. Then 6 will go into the print line. So the value will be the value of x is 6. That should be the printout to the command line.
Okay, so what kind of function is the plus one?
Is a return function or something like yeah. Function that returns, yeah. Something like that.
A returning function.
Yes.
Yes, yes. Thank you. So that is turning this to between the value of x is 6. Okay? Let's see. This one is the value of x is 6. So you're correct. Mm. So they said there's an error here. So who can tell us the error? Who can figure out the error? Yeah.
Because of the semicolon at the end of x plus 1 will show an error. Are you with me?
Mm. Mm. Yes, yes, yes. I've done it. Thank you, sir. Thank you.
All right.
All right. So I think that is all for functions. Let's go to comments. So comments in every programming language is just the same thing. Comments are codes that the compiler will ignore. And here we use the double slash to comment out things. I've always been writing, I think I've deleted the code, but I was writing some comments before. So all programmers have to make their code easy to understand, but sometimes extra explanation is warranted. In this case, programmers leave comments in their source code that the compiler will ignore, but people reading the code will find useful. So I think this is not a big deal. Let's go to control flow. The ability to run code depending on a condition is true. So control flow is just like your if else statement in other programming languages. But yeah, we have okay, the if expression, and if expression allows you to branch your code depending on the condition. You provide the conditions and then state if the condition is met. Run this code of run this code of loop. If the condition is not met, do not run this code of loop. This is what it's saying. Let number equals to 3. So the number is 3. So now saying if number is less than 5, if you run this code. Else, if this number is not less than 5, if you run this code. So what will be the answer of this code of this block of code?
Condition
Hmm?
was true.
What will be the answer now?
Condition was true.
Alright, alright. You're right. Condition is true. Then let's try changing the let's see. Mhm. Then let's change this to like 10. What will be the answer?
Condition was false.
Let's see. Okay. So let's move to an example where we handle multiple conditions. Else if this one we need is just else. And this we are doing else if is just the same thing in JavaScript. But let's just to fulfill our righteousness. Let number equals to 6. If number modulo 4 is equals to 0, return this. If number modulo 3 is equals to 0, return this. If number modulo 2 is equals to 0, return this. Else, number is not divisible by 4, 3, or 2. But the answer here is already number is divisible by 3. Did anybody not understand this code? Should we go by it again? Should I go over the code again?
I think we are good now. Let's go.
So there's another reason if in a let statement. So because it is an expression, we can use it on the right side of a let statement to assign the outcome to a variable. Let's see what they are saying. Condition is true. Then times times else. Fix. So who can explain what this thing is doing? Just you can guess, you can try.
Can we see? Okay.
Someone should explain to us, please.
Can I try? Maybe. Mm, the condition was declared as true. Okay, I can't see the screen.
Of course, you can say. You can say,
So condition was declared true. So in the line 3, there was checking if condition is true or is false. So in this case, in which condition is true, I think is returning the value, which is 5, into the in which it will be stored in number. Then that 5 will be printed in line 5. So that is just so the answer should be the value of number is 5. That,
I think so too. I think so too, man. The value of the
yes,
number should
well,
be 5, but the 6, we have two values there, and then they are printing number. So I don't know which of the number to actually will actually come. Is it 5, 6 together, or that's where my confusion is coming from now.
now when we are doing, when we did this um, control flow, control flow said if a condition is met, it runs a block of code, right? This is what the documentation says. And when we ran this, we got let's number 3. Let number equals to 3. And now the first condition is if 3 less than 5. And we all agree that yes, 3 is less than 5. And then we printed this block condition was true, right? So it's just the same thing here. Now the only difference is that we are just using our if else block. But Ross have their own kind of thing where you use if in a less statement. So the whole okay, let me clear your confusion. This is what this is what it means here. So this line 5, mm, this line 3, and this whole block of code is saying the same thing. Do you understand?
Yes, we
Do you
understand.
understand?
We understand. So now, what will be the value of the number?
What? I didn't get to what you said. It's similar to
I said,
similar.
so now,
Yes, it's
for
similar.
more, okay, I understand. I understand the if else statement. I understand. So, but now we are returning and we are
So
printing the value
if
of the number. So, what is the value? What would should be our value? What will be number in our console?
our value is
Okay.
five. So the whole essence of this um, if if a let statement is to we know that this condition the answer is five. But now in order to print it to the console, it needs to be stored in a variable. That is why we have the let statement because we are initializing a variable called number and then we are binding it to the outcome or the result from this condition. That is the whole concept of if in a let statement. Do you understand? Exactly.
Ma, hello. The way we
I
return,
can hear you.
the way we return number like this, is it possible for us to return string also similar like this? Like to return string
Huh?
like the way we return number like this, like this 5 and 6, in which it was declared a number. Is it
Mhm.
possible for us to return string also, like a string value, maybe yes
Yes,
and no or something like that? Okay.
yes. Let me show you. The only thing now is that I have to change this data type here to string, change it to string, change it to string five. Hello. Okay. Then change it to string of three. Then we'll do our console three whatever. This is it returns
It worked.
the value of number is high. This is
Yes, I saw it. It worked. Thank you.
all right. So then when it loops is like going executing a block of code over and over again forever until you tell it to stop or until a certain condition is met. So this is a infinite loop print again. So this block of code is going to keep printing again. Let me show you. The only thing is that my system will start it because it will be taking A lot of space. Okay. I can't even see how many again it has written, but it's just going to be running. Okay. So this is the very bad way of writing loops. Returning values from loops. Yes. One of the uses of loops is to return an operation might fail, such as checking whether a train has completed its job. You might also need to pass the results of that operation out of the loop to the rest of your code. To do this, you can add the value you want to return after the break expressions. We use we use to stop the loop. Okay, all those big grammars. This is what they are saying. We created a mutable variable called counter and assigned a zero to it. Then we created another value and started looping through it. So in this value increase counter by one. Hmm? So it keeps increasing this counter that is zero by one. Then we have a condition that when counter is equals to 10, you should break it, you should stop the loop and then counter, multiply counter. That means for this for this loop to finish now, counter has to be 10. And when counter is 10, you multiply
Makunungo.
10 times 2. And then you
Di makunu.
Yes, can you mute?
Eh? Eh?
Can you guys hear me? Yes. So do you guys understand this code?
Ooh.
Hmm?
There's the main. There's the cathedral, bro.
Mm, that line 8 is the only place I'm a little bit confused. Because why are they multiplying it by 2 again?
Okay. Okay. It's good they ask. Mm. Let me realize now. Let's say in a game you can look that players that get
The
to
2 o'clock in
10
the grind.
in so time. That once this player gets to be this time use. So once the player gets to this particular number, then okay, the first player that
Right.
gets to this particular
Oh.
number, then you increase.
Nah, nah, please, dude. Okay. I should drink kunu. I should finish the kunu. Eh.
No, I said that. Alright, I can see that the person has written it. Okay, so your question is why are we multiplying it by two? Is the logic.
Yes.
The first person that gets to this number increase their points by two.
Okay.
Do you understand?
Apart from that counter, so we can break normally too
So
without adding that, right?
yes, yes,
Is it possible? Okay.
let's
Can we
let's
just
try it.
break?
Let's
Maybe
let's
if it's equals to 10, then we break
let's run this
normally.
one. Yes, you can do that. So let's hold this counter now.